Hello. In the preceding videos, we introduced the brute force algorithm and the Boy-Moore algorithm for string matching. In this video, we'll introduce the Morris-Pratt algorithm, known as the Kmp algorithm. The Kmp algorithm is efficient. It achieves order of m plus n in the worst case. It is optimum because every character in the text and in the pattern must be checked at least once in the worst case. In the brute force or the Boy-Moore algorithm, once a mismatch is found, the algorithm restarts to search for the next possible match by shifting the pattern one position to the right for the brute force algorithm and possibly multiple positions to the right for the Boy-Moore algorithm. In doing so, the successful match of characters prior to mismatch is ignored. The Kmp algorithm takes consideration of the successful matches to find the maximum number of positions to shift in the pattern before continuing next search. To remember this, to consider what you have searched, we introduce the failure function. We define fail k as the length of the longest prefix of the pattern, that is suffix of pattern 0 to k. For example, this is C at this index 5. So fail 5 is 3 because this suffix ABC matches the prefix ABC, the longest. This B at this index 4, fail 4 is 2 because AB matches AB right here. And this C right here at index 2, fail 2 is 0 because there's no prefix matches any of the suffix here. This fail function gives some information about how far you are doing this searching and how much is matched when you do a slide accordingly. Let's look at the animation. I'm going to use the default input for text and a pattern. This is the failure function. It can be pre-computed. I'm going to do a search now. This is the pattern, this is the text, and here we're going to start from the first one. This is the index, is
the characters, A versus A.
I,
match. Next,
K.
I will be 1 and K will be 1.
I is the index at this text. K is the index for the pattern. They're both 0 matched. And the next one will be I will be 1 and K will be 1.
The characters, B versus B, match. Next, I will be 2 and K will be 2. The characters, C versus C, match. Next, I will be 3 and K will be 3. The characters, A versus A, match. Next, I will be 4 and K will be 4. The characters, B versus B, match. Next, I will be 5 and K will be 5. The characters, C versus C, match. Next, I will be 6 and K will be 6.
All right, so the next here, right here, I is 6 and K is also 6. A and D do not match. And then what you have to do is to slide the pattern as many characters as you can to the right. So how far you're going to slide, it is dependent on, see here we have already have this matched this at this position, ABC. We have this 3, ABC, ABC. So we're going to slide all the way here, 3 positions, slide. Let's look at the next one here is
the characters A versus D don't match. Next K will be FK minus 1, which is 3.
I will be 6, no change. And K will be changed to this position here. You're going to slide because all of this right here and this AD do not match, but everything here matches. So we're going to look at this now and slide. This is suffix and the prefix matches it. So we don't have to recompare it. We can just slide here.
The characters A versus A match. Next, I will be 7 and K will be 4.
Continue.
The characters B versus B match. Next, I will be 8 and K will be 5. The
Continue.
characters C versus C match. Next, I will be 9 and K will be 6.
All right, so the next one here, A and D will not match. And then we're going to slide the, how many positions is this going to be? K is going to next one, next K will be, this K will be 6. So the previous one is fail 5, that's 3. So it's going to be 3 positions.
The characters A versus D don't match. Next K will be FK minus 1, which is 3. The characters A versus A match. Next, I will be 10 and K will be 4.
Now you're going to continue and everything is going to match. So the algorithm here, you have these 2 indices, I and K. I is always moving forward. It's on this text. And a K is the index on the pattern. So if K increases, you just move to the next position. And if you have K decreases, you're doing the sliding. So every time when you do the comparison, you're going to see you are moving forward. This is for the I or for the K, for this, anything here on the K here. All right, so the fail function can be computed similar to the Kmp algorithm. I'm going to have you just read the book, and the book also gives the complete description of the algorithm and the complete program. So this video serves as the overview and the guideline and to help you to get into the algorithm. Thank you for watching this video. See you on the next video.